A signal from deep space, a planet that defies all expectations, and a race to another star. What if everything we thought we knew about the universe is about to be shattered? The James Webb Space Telescope, JWST, has uncovered secrets so shocking that they could rewrite the rules of life itself. But is Proxima B truly a new Earth, or a deadly trap in the vastness of space? The James Webb Space Telescope, often hailed as humanity's most advanced eye in the sky, has recently turned its gaze toward one of the most intriguing exoplanets ever discovered, Proxima B. This distant world, orbiting the red dwarf star Proxima Centauri, has captivated scientists and enthusiasts alike since its discovery. But now, with the unparalleled capabilities of the JWST, we are finally getting a closer look at this mysterious planet, and the revelations are nothing short of extraordinary. Proxima B was first detected in 2013, but it wasn't until the James Webb Space Telescope came into the picture that we could truly appreciate what lies on this distant world. The telescope's ability to capture infrared images has allowed astronomers to peer into Proxima B's atmosphere, revealing details that were previously hidden from view. What they found has sparked both excitement and concern. You see, Proxima B orbits its star at an incredibly close distance, just 7.3 million kilometers away, which is less than 5% of the distance between Earth and the Sun. This proximity means that the planet completes a full orbit in just 11.2 Earth days. But what makes this even more fascinating is that Proxima Centauri, the star it orbits, is a red dwarf. Unlike our Sun, which is a relatively stable star, red dwarfs are known for their volatile nature, often emitting powerful solar flares that can drastically affect the planets orbiting them. Now, here's where things get even more interesting. The JWST has provided the clearest image yet of Proxima B, and it's revealed some startling features. For one, the planet is about 30% more massive than Earth, which means it has a stronger gravitational pull. But what's truly shocking is the possibility that Proxima B is tidally locked with its star. This means that one side of the planet is in perpetual daylight, while the other is shrouded in eternal darkness. Imagine the kind of world where the sun never sets on one side, and the other is plunged into an endless night. This tidal locking creates a harsh environment for any potential life forms. The side facing the star would be scorched by constant radiation, while the dark side would be a frozen wasteland. This raises a critical question. Could life ever survive in such extreme conditions? The possibility seems slim, but nature has a way of surprising us. But the challenges don't stop there. Proxima Centauri itself poses a significant threat to the habitability of Proxima B. The JWST has revealed that the star is far more active than previously thought. Its powerful magnetic fields produce intense solar flares that bombard Proxima B with high-energy radiation. In fact, a flare observed in April 2021 was 100 times more powerful than any flare ever seen from our Sun. Such a massive burst of energy could strip away the planet's atmosphere, leaving it exposed to the harshness of space. Some researchers argue that Proxima's proximity to a star and the frequent solar flares make it unlikely to support life as we know it. Others, however, suggest that life might find a way to adapt to these extreme conditions. Could there be organisms on Proxima B that have evolved to survive in such a volatile environment? Or is the planet doomed to remain a barren rock devoid of life? As we continue to explore Proxima B with the James Webb Telescope, more secrets are sure to be uncovered. But one thing is clear. This tiny planet, just 4.24 light-years away from us, is far more complex and enigmatic than we ever imagined. Could it be that Proxima B holds the key to understanding the limits of life in the universe? And if so, what does that mean for our search for extraterrestrial life? One of the most shocking discoveries was the planet's atmosphere, or rather, the potential lack thereof. The intense radiation from Proxima Centauri, combined with the planet's close orbit, means that Proxima B is constantly bombarded with solar wind and high-energy particles. Over time, this relentless assault could have stripped away the planet's atmosphere, leaving it barren and exposed to the cold vacuum of space. But here's where things get interesting. Some scientists believe that Proxima B might still retain a thin atmosphere, possibly composed of heavier gases like carbon dioxide or nitrogen, which could provide some level of protection from the star's radiation. The James Webb Space Telescope has given us the clearest glimpse yet of Proxima B's surface, and what it has revealed is both fascinating and mysterious. The planet's surface appears to be rocky, much like Earth's, but with significant differences. For instance, the side of the planet facing Proxima Centauri is likely scorched by constant heat, creating a barren, desert-like landscape. Meanwhile, the dark side of the planet could be a frozen wasteland, with temperatures plummeting to levels far colder than anything experienced on Earth. But the most intriguing possibility lies in the narrow strip of land between these two extremes, known as the twilight zone. This area, where day meets night, might offer more temperate conditions where liquid water could exist. The existence of liquid water is, of course, one of the key ingredients for life as we know it. Could this twilight zone harbor a hidden oasis where life has managed to take root despite the harsh conditions on the rest of the planet? Another stunning revelation came when scientists examined the possibility of water on Proxima B. If water exists on the planet, it would likely be in the form of ice on the dark side, or small, possibly temporary bodies of liquid water in the twilight zone. But the discovery that shocked many was the potential for subsurface oceans, similar to those found on moons like Europa or Enceladus in our own solar system. These oceans could be heated by the planet's core or by tidal forces caused by Proxima B's close orbit to its star. If such oceans do exist, they would be a prime location to search for life hidden beneath the planet's icy surface. But let's not forget the potential challenges. The magnetic field of Proxima Centauri is another factor that adds complexity to the planet's environment. Recent studies suggest that the star's magnetic field could interact with the planet's core, generating its own magnetic field. This interaction might protect the planet's atmosphere from being completely stripped away by solar wind, much like Earth's magnetic field protects us from the sun's radiation. However, the situation on Proxima B is far from straightforward. The star's powerful flares could overwhelm the planet's magnetic defenses, leading to dramatic and sudden changes in the planet's climate and surface conditions. These discoveries raise more questions than answers. If Proxima B does have a magnetic field, how strong is it, and how does it influence the planet's atmosphere and potential for life? Could life on Proxima B have evolved to survive the planet's harsh and fluctuating conditions? And if life does exist, what form would it take? Would it be something entirely different from anything we've seen on Earth? Or could it share similarities with extremophiles that thrive in Earth's most inhospitable environments? While the idea of a habitable planet orbiting Proxima Centauri is captivating, the reality is far from hospitable. The James Webb Space Telescope has provided unprecedented insight into the challenges any potential life on Proxima B would face, and the picture is anything but rosy. One of the most significant challenges is the planet's exposure to extreme levels of radiation from Proxima Centauri. Unlike our Sun, Proxima Centauri is a red dwarf star with a much smaller mass and a much more chaotic surface. This star's proximity to Proxima B means that the planet is constantly bombarded with intense solar radiation, including powerful flares that can be 100 times stronger than those emitted by our Sun. These flares produce a deadly cocktail of ultraviolet and X-ray radiation that would be lethal to any life form similar to those on Earth. The effects of this radiation are not just theoretical. In April 2021, a particularly massive flare from Proxima Centauri was detected, and it was strong enough to potentially strip away any atmosphere that might have existed on Proxima B. This event serves as a stark reminder of the dangers posed by red dwarf stars and casts doubt on the likelihood of Proxima B being a haven for life. Moreover, the constant exposure to such radiation would make the surface of Proxima B an incredibly hostile environment. Any water on the surface would be rapidly vaporized, and the planet's rocky landscape would be scorched by the relentless heat. The dark side of the planet, while not exposed to direct radiation, would be equally inhospitable due to freezing temperatures. This extreme dichotomy between the scorching day side and the frozen night side leaves little room for a stable, life-sustaining environment. #### the race to reach Proxima Centauri. While the signal from Proxima Centauri remains a mystery, the idea of actually reaching the star system has moved from the realm of science fiction to a genuine scientific endeavor. The Breakthrough Starshot Initiative, spearheaded by a team of visionary scientists and backed by prominent figures like Stephen Hawking and Yuri Milner, aims to send tiny, laser-propelled spacecraft to the Alpha Centauri system, including Proxima Centauri, within our lifetimes. The concept behind Breakthrough Starshot is as ambitious as it is revolutionary. The plan involves launching thousands of tiny spacecraft, each about the size of a postage stamp, into space. These star chips would be equipped with cameras, communication equipment, and sensors to gather data as they make their journey to the nearest star system. But what makes this mission truly groundbreaking is the propulsion system, powerful ground-based lasers that would accelerate these miniature spacecraft to a staggering 20% of the speed of light. At this incredible speed, the star chips could reach Proxima Centauri in just over 20 years, a blink of an eye in cosmic terms. Once there, they would transmit data back to Earth, giving us our first close-up look at Proxima B and the other planets in the Alpha Centauri system. The technology behind this mission is still in its early stages, but the progress made so far has been nothing short of remarkable. #### challenges of the mission and implications for the future. The idea of reaching another star within our lifetimes has captivated scientists and the public alike, but it also presents significant challenges. One of the biggest hurdles is the sheer amount of energy required to propel these spacecraft to such high speeds. The lasers needed for this mission would require around 100 gigawatts of power, equivalent to the total electrical output of the United States at any given moment. This energy would have to be concentrated into a precise beam aimed at the tiny spacecraft, accelerating them over a period of minutes until they reach their target velocity. Another major challenge is the spacecraft themselves. Traveling at 20% of the speed of light means that even tiny particles in space could cause catastrophic damage to the star chips. To mitigate this risk, the spacecraft will need to be equipped with advanced shielding, and their trajectory must be carefully calculated to avoid areas of space with high concentrations of dust or debris. Additionally, the star chips must be able to withstand the intense heat generated by the lasers and the extreme conditions of space. But perhaps the most intriguing challenge is what happens once the spacecraft reach their destination. The signal sent back to Earth from Proxima Centauri will take over 4 years to arrive, meaning that even after the star chips complete their journey, it will be several more years before we know whether the mission was a success. And if we do receive data from Proxima B, what might it reveal? Will we finally see clear evidence of an Earth-like planet? Or could we discover something entirely unexpected? The implications of reaching Proxima Centauri are profound. If successful, this mission could pave the way for future interstellar exploration, potentially allowing us to visit other star systems and even discover new worlds that could support life. But the mission also raises ethical and philosophical questions. What if we do find evidence of life, intelligent or otherwise? How should we respond? And what if our arrival in another star system is perceived as a threat? As Breakthrough Starshot continues to develop, the race to reach Proxima Centauri is heating up. The possibility of exploring another star system is no longer just a dream, it's becoming a reality. As the star chips prepare for their journey, one thing is certain. The race to Proxima Centauri is just beginning, and the discoveries waiting for us could change everything we know about our universe. #### new insights and uncharted possibilities. While much of the focus on Proxima B revolves around its potential habitability, there are still so many unknowns about this planet that it could take decades or even centuries before we fully understand what lies there. The James Webb Space Telescope has certainly made major strides, but it is only one tool in a much larger cosmic investigation. Other telescopes, space missions, and theoretical models will be essential for piecing together the full picture of Proxima B. One promising avenue of research is studying the planet's geophysical properties. For instance, scientists are particularly interested in the planet's internal structure, which remains mostly a mystery. The fact that Proxima B has a higher mass than Earth suggests that it could have a more robust core, possibly even generating its own magnetic field. Such a field could serve as a crucial shield, protecting the planet from the star's ferocious solar flares. However, as the magnetic field of Proxima Centauri itself is so erratic and dynamic, it's unclear whether Proxima B could generate a field strong enough to provide long-term protection from the cosmic radiation bombarding it. Another factor complicating our understanding of Proxima B is its likely composition. Given its Earth-like mass, it's plausible that Proxima B could be rocky, with a landscape that includes vast plains, towering mountains, or deep valleys. However, without knowing the planet's exact chemical makeup, it's impossible to say for sure whether its crust is made of silicate materials, metals, or some combination thereof. Adding to the intrigue is the possibility that Proxima B could have experienced tectonic activity at some point in its past, leading to a diverse and dynamic surface. If tectonic plates have shifted over millennia, this could have contributed to the development of surface features similar to Earth's mountain ranges or oceanic trenches. If such processes are still happening today, it could further complicate the task of determining the planet's habitability. The existence of potential subsurface oceans also presents fascinating questions. If liquid water exists beneath Proxima B's surface, shielded from the harsh surface conditions, it opens up the possibility of an ecosystem thriving in these depths, similar to life forms found in Earth's own deep oceans. Hydrothermal vents, common on Earth's ocean floors, could provide the necessary energy for such ecosystems to survive in complete isolation from sunlight. Finally, while the conditions on Proxima B may seem inhospitable to human life, that doesn't rule out the possibility of microbial life forms surviving in extreme environments. Extremophiles on Earth, organisms capable of thriving in extreme heat, acidity, or radiation, suggest that life could exist in places we once thought impossible. The hunt for answers continues. While Proxima B's distant location presents major logistical challenges, it also offers humanity a once-in-a-lifetime opportunity to explore a new world. Whether the planet holds life or is just another barren rock, our exploration of it will teach us valuable lessons about the limits of life and the vast potential of the universe beyond our own solar system.